Hi y'all, this is the review video for your upcoming test over rational functions. This is going to be a difficult test, probably one of the most difficult ones that you're going to take all year. So if you get stuck through the video, it's okay. Just pause me, go back, and re-listen to what I'm saying. If you feel like you're confident enough to try some on your own, please do that, and then go back and check if it matches the video here. Okay, so the first two questions on your test are going to be over graphing. For number one, remember that whatever number is in the back here, this is going to be your horizontal asymptote, and whatever number is on the bottom is your vertical asymptote, and we always flip the sign on that because the sign is opposite whenever you're talking about x plus or minus something with regard to transformations, okay? So your x equals for the equations of the asymptotes, that is going to be your vertical asymptote, and y equals is going to be your horizontal asymptote. So I already know y is equal to 3, and my vertical asymptote is equal to 4 because I'm flipping the sign beside x. Your domain and range depend on the vertical asymptote and the horizontal asymptote respectively. So your domain is going to be negative infinity to whatever the vertical asymptote is, which is 4, union 4 to infinity. Your range is going to be negative infinity to whatever your horizontal asymptote is, which is 3, union 3 to infinity. The transformation, let's do holes next. You didn't cancel anything here, so there's no holes. So we're just going to put none. Your transformations that are happening, I've got a x minus 4 on the bottom, which is going to move my graph right 4. And I've got plus 3 on the outside after the fraction, so that's going to move me up 3. So when I draw on my asymptotes, I've got 1 at positive 4. It's right here. And then I've got 1 up 3 at positive 3. So this is y equals 3. And this is x equals 4. Okay, so when I graph this, you can use your calculator for it. It'll probably be more accurate than my freehand drawing, but it's going to look something like this. There we go. Okay, and we are good with number 1. Moving on to number 2. I need to simplify this first before I can do anything else. So on the top, I've got x plus 5. On the bottom, it's going to factor into x plus 5 times x minus 5 because it is a difference of squares. So if you aren't comfortable with that and you want to factor it using the I, you'd have negative 25 on top and 0 on the bottom because you're missing an x term. So the coefficient in front of x, since you're missing it, is 0. So the two numbers that would give me that are 5 and negative 5. Notice now that the x plus 5 on the top and the bottom are going to cancel, and that's going to simplify to 1 over x minus 5. That is our final simplified answer. Okay, so right off the bat, I canceled x plus 5. That means that I have a hole at negative 5, so x cannot be equal to negative 5. In order to figure out the actual coordinate point of the hole, I have to take that domain restriction or that hole that I've got, and I'm going to evaluate it in my simplified function. So your simplified function was 1 over x minus 5. Instead of putting an x, I'm going to substitute it with a negative 5. So I'm substituting this negative 5 in that x. So I've got 1 over negative 5 minus 5. So I've got 1 over negative 10. So my hole is going to be at negative 5 and 1 over negative 10. So negative 5. Negative 1 over 10 is a super, super small number, so the hole is going to be about right there. Okay, With regard to your asymptotes, remember that x equals is your vertical asymptote, y equals is your horizontal asymptote. If I wanted to, I could rewrite that simplified form with a plus 0 in the back. Notice that there's nothing being added or subtracted in the back of the fraction. That means that your y is equal to 0. You can also think about it with that funky acronym, the Bobo Botan Eats DC. Notice that this is Bobo because the degree of the denominator is 2, the degree of the numerator is 1. When I say degree, I'm referring to the exponent. So this x has an exponent of 1. 1 is smaller than 2, so the degree of the bottom is bigger than the degree of the top, so you have y equals 0. Your vertical asymptote, we're just looking at your h value here, and we're going to flip the sign. So since I have -5 down there, my vertical asymptote is going to be at +5. So I've got an asymptote here, and then I've got one at y equals 0. So this is x equals 5. This is y equals 0. So I know that my graph is going to look something like this, and I'm not going to fill in the hole. It's going to go down like that. It's kind of ugly. Oh well. And this is going to extend out, so you're going to go like this. Okay, your domain is based off of the vertical asymptote, and the range is based off of the horizontal asymptote. So my domain is going to go from -infinity to 5, and then from 5 to infinity. Your range is going to go from -infinity to 0, and then 0 to infinity. Transformations that are happening here, the only thing that's happening is we're moving to the right 5. The top, we're not going to say there's a vertical stretch of 1 because the parent function already includes a 1 on the top. Okay, so we are done with that question. That is the graphing portion of your test. Let's take a look at the second page of the review. So number 3, you're going to be asked to list the transformations of the parent function. Remember that your parent function is y equals 1 over x. And this is the general form for transformations. Your a value is a vertical stretch or vertical shrink. Your h value moves you to the left or right, and then k moves you up or down. So our a value here is 4. Since that's bigger than 1, that means you have a vertical stretch. Your h value here is 2, and it always flips signs. So usually you associate minus with left, but now we're actually moving to the right. So that's going to move you to the right too. And we have no plus k on the outside, it's just 0. So I haven't moved up or down any from the parent function. So these would be the 2 transformations being applied there. And if you want to put vertical stretch of 4, that's fine. Okay. For number 4 and 5, we are figuring out the excluded values. So when we're talking about excluded values, that's when I'm talking about the denominator not being allowed to be 0. So I really only care about the denominator here and here. I don't really care what the numerator is until I start canceling. So when we simplify this, 5. On the bottom, that's going to factor into x plus 5 times x minus 5. And that is the difference of squares pattern. Again, if you're having trouble factoring that, we need factors that multiply to -25 and add to 0. So it's -5 and +5. I can cancel these, and when you simplify it, you get this. But remember, I'm looking at the original denominator. So even if I canceled that factor, I still have to take it into account when I'm doing that domain restriction or excluded values. So for this question, I'm going to look at the denominator, and I'm going to flip the signs. So x cannot be equal to -5 or +5. Okay. For number 5, the top part, when we factor it, we've got -81, we've got 0. So your 2 numbers are -9 and +9. I can cancel these out and you're just left with x plus 9. So I still need to worry about the original denominator though, that x minus 9. So you're going to flip the sign. So you say x cannot be equal to positive 9. So even though these functions, when you simplify them down, you might get something that has no denominator or that cancels. If something cancels, you still have to include it in the domain restriction. So always look at the original denominator, whether that denominator is in factored form or it's in standard form. Either way, use the original denominator for those excluded value problems. For number 6, what mathematical operations do you need a common denominator for? So an operation is addition, subtraction, multiplication, or division. When you multiply and divide, you do not need a common denominator. You're not combining anything the same way that you are with addition and subtraction. Think about like regular fractions. If you were going to multiply 5 over 3 times 1 over 2, I don't have to find a common denominator. I'm just going to multiply the tops together and the bottoms together and get my answer. I didn't have to find a common denominator. When you're adding and subtracting fractions, you do have to find a common denominator. So the only two that apply here are addition and subtraction. Okay. Number 7 and 8, we are simplifying and then listing those domain restrictions. So for number 7, you see quadratics, you want to factor those. So I'm going to factor the top and the bottom. So I've got things that multiply to 25 and add to 10. Got positive 5 and positive 5. So this numerator goes with this factored form. And then I want to factor this. So I need things that multiply to negative 20 and add to 1. So I've got 4 and 5, and I want a negative 4. 5 minus 4 is positive 1. 5 times negative 4 is negative 20. So we've got y plus 5 times y minus 4. And this denominator is going with this factored form. Okay, there's no flipping, multiplying and flipping here because there is no second fraction that you're dividing by. It's just one fraction that has the division in between it. Okay, so now we look for things that we can cancel. I can get rid of this y plus 5 and this y plus 5, and I'm left with y plus 5 over y minus 4. You cannot cancel both y plus 5s on the top with one y plus 5 on the bottom. It has to be the exact same for you to cancel it. So I can't cancel 2 copies of something with 1 copy of something else. It has to be 1 copy and 1 copy. So this would be your simplified form, and your domain restriction here would be looking at the original denominator, so the one that I circled in blue. I'm going to flip the signs of those factors. So y cannot be equal to negative 5 or positive 4. Okay, moving on to number 8. This one is already in factored form for you. You don't have to factor it. You just have to be able to identify which ones are the same. So I can get rid of the x minus 2's, and I'm left with x plus 4 over x plus 1. And that's your simplified form. Looking at the original denominator, so you're looking at, trying to find a different color, you're looking at what I'm circling in yellow here. That is what you're using for your domain restriction. So we are going to restrict positive 2 and negative 1. So that would be your final simplified answer and the domain restrictions that go with it. Okay. Slide 3, page 3 of yours, we are multiplying these things together. Remember that when you're multiplying, you do not need a common denominator. So you're going to make way more work for yourself. You don't need a common denominator. You are going to cancel whatever you can after you factor. So the only thing that we can factor here is x squared minus 36. That's going to factor into x plus 6 times x minus 6. If you want to make the I things that multiply to give you negative 36 and add to give you 0, 6 and negative 6. So now I've got x plus 6 over x squared times 5x over, now I'm going to use the factored form of this. So we're going to have x plus 6 times x minus 6. And notice at this point I can cancel these x plus 6's, and you're left with 5x over x squared times x minus 6. Okay, there is actually one more cancellation I can make here. Remember that x squared means that you have two copies of x that are being multiplied together. So this is really what's happening. So I can cancel out one x from the top with one x from the bottom. So now you've got 5 over x times x minus 6. I got rid of a copy of x on the top and a copy on the bottom. So this would be your fully simplified answer. Your domain restriction here, you're looking at the original factored denominator. So we know we're taking into account this denominator as well. X squared cannot be equal to 0, and x squared minus 36 cannot be equal to 0. To solve x squared not equal to 0, the only number squared that will give you 0 is 0. So x cannot be equal to 0 is one of those restrictions. When we factored this, we got this. So I'm going to restrict negative 6 and positive 6 from my domain. So those are my two domain restrictions. Okay, number 10, this is division. So this is where you're going to flip the second fraction and multiply. So the question you're really answering, you're going to multiply by the reciprocal of this fraction. Reciprocal just means to flip the top and the bottom. So this is what we're solving. So we need to factor the quadratic that I've got. This is going to factor into x plus 4 times x minus 4. If you want to use the I, you've got factors that multiply to negative 16 and add to 0. Those two numbers are 4 and negative 4. So this and this are the same thing. One's just in factored form. Okay, and I can I can cancel those two things. So you're left with x minus 4 over 3 times 9. Okay, there's a number of different ways that you can go about this in terms of reducing. If you notice that you can take the 3 away from here, and I can factor a 3 out of the 9, that's fine, and you get 3 times x minus 4. If you distribute, you get 3x minus 12, and that's your final answer. Or if you want to, you can say, I'll do it over here. So if you're not comfortable with that reducing that I just did, we can multiply numerator, numerator, denominator, denominator. You get 9 over x minus, or times x minus 4 over 3. And at that point, you can recognize 9 divided by 3 gives me 3. So I'm right back to where I would be distributing. So either way you do, it's fine. So final answer there is 3x minus 12. Your domain restrictions. Your original denominators in the problem were 3 and 9. So 3 and 9 are never going to be 0. There's nothing I can do to make those numbers equal to 0. So for this problem, we're going to say that there are no restrictions. Okay, moving on. Number 11, hint, they must have a common denominator. So if you're struggling on your test with that one question, if you go to question 11, you'll see the hint that sum or difference, meaning addition or subtraction, you have to have a common denominator. So we actually put one of the answers to the test question within the test. Here, adding and subtracting, you do need to have that common denominator. So this is one of those special cases. X minus 2 and 2 minus x are not the same. You have a positive x and a negative x, a negative 2 and a positive 2. So I'm going to leave the first fraction alone. And on the second fraction, my common denominator, I want to make it x minus 2. So in order to get the bottom to change sign, I'm going to multiply it by negative 1, and I'm going to do the same thing on the top. So this is what we've got. So if you do 2 minus x times negative 1, you end up getting negative 2 plus x, which is the same thing as x minus 2. So now you've got the same denominator. Okay, so all you have to do now is combine your like terms. So your denominator is x minus 2. I've got 3x plus 4 minus 3. 4 minus 3 are like terms, so you have 3x plus 1 over x minus 2. And that's going to be your answer here. Your domain restriction, I'm going to flip the sign of my original denominator. So my original denominator was x minus 2 and 2 minus x. Both of those cases, x cannot be equal to 2. So that would be your domain restriction and your simplified answer. For number 12, they already have the same denominator. They already have an x plus 5 on the bottom. So I don't have to multiply by anything because they're already the same. All I have to do is combine the like terms on the top. So whenever we have a minus sign, I'm always going to put fractions. I'm always going to put parentheses around the second fraction so that I remember to distribute the negative sign. So you've got minus 3x minus 4 over x plus 5. And then combine your like terms here. So these two are alike, and these two are alike. So x minus 3x gives you negative 2x, and negative 2 minus 4 gives you negative 6 over x plus 5. So that is your answer. And your domain restriction, we're going to flip the sign of the original denominator, so x cannot be equal to negative 5. Okay, number 13. A couple different methods you can use here. If you want to use the common denominator method and you want to find the common denominator between 5 and 2, which is 10, you can do that. Or you can cross multiply. So either method that you want to use is fine. So if you like the common denominator method, I'll do that one. So our CD is going to be 5 times 2, which is 10. So in order to get to 10, I had to multiply by 2 on the bottom. For the second fraction, in order to get to 10 on the bottom, I had to multiply by 5. Okay, so you've now got 2x over 10 is equal to 15x plus 45 over 10. And the denominators are the same, so you can get rid of them. And we set 2x equal to 15x plus 45. I want to get all my x terms on the same side, so I'm going to subtract 15x from both sides. And then I'm going to divide both sides by negative 13. So we've got negative 45 over 13. And that's our answer. If you like to cross multiply, you're going to get, so cross multiply, you're going to multiply these two together and multiply these two together. You've got 2x is equal to 5 times 3x plus 9. So you've got the same thing that you did on the other one. And I'm not going to solve it from there. You're going to get the same exact answer as you did on the other one. So whatever method you're most comfortable with, use what you like, okay? Notice that the denominators here are 5 and 2. So 5 and 2 are never going to be 0, so there are no domain restrictions. There's no variable on the bottom. Okay, number 13. I'm going to cross multiply this one. So we've got these, we've got these. So you've got 3 times 3x plus 10 equals 5 times x minus 2. And you're going to distribute what's in front. You want to get all your variables on one side and all your constants on another side. So I'm going to subtract 5x from both sides, but you can do whatever you want. And then I'm going to subtract 30 from both sides. And divide 4 on both sides. So we get x is equal to negative 10. Okay, your domain restrictions here. So your two denominators are x minus 2 cannot be 0, and 3x plus 10 cannot be 0. On this one, we're just going to flip the sign because there's no number in front of the x. On this one, we're going to have to do a little bit more work. So I'm going to solve this as if it were equal to 0. So you get 3x is not equal to negative 10. Divide both sides by 3. X is not equal to negative 10 over 3. So neither of those domain restrictions apply to our solution. Our solution is negative 10. Neither of those numbers are negative 10. So negative 10 is a valid solution here. We made it to the last page. Awesome. So for number 15, we are still solving. I'm going to use cross multiplication on this one. So we're going to multiply these and these. So we've got x plus 3 times x minus 3 equals negative 8x. And in order to multiply those two things together, the two binomials, we're going to use box method. And notice that when you combine these two like terms, they cancel each other out. So you just get x squared minus 9 is equal to negative 8x. I want to move that negative 8x to the other side. I cannot combine that with anything, so I'm just going to put it in the middle so I can factor this. So I need two numbers that multiply to negative 9 and add to 8. So I've got 9 minus 1 gives you 8. So we've got x plus 9 times x minus 1 equals 0. And in order to solve this, I'm just going to flip the sign of my factors. So x is equal to negative 9 and positive 1. Our original domain restrictions are coming from the original denominator, so x cannot be 0 and x minus 3 cannot be 0. So here's one restriction, and there's the other one. Notice that none of the answers that we got are in those restrictions, so the two answers that we got are valid. For number 16, you do have to find a common denominator because you are adding. So the common denominator here is going to be x. I don't really care about the right-hand side right now. I just care about combining the left-hand side. So in order to get 1, that's the same thing as x over x because I'm dividing this something by itself. So x over x plus negative 2 over x is 24 over x squared. If you combine on the top, you've got this. And now you can cross multiply. Okay, so we've got x squared times x minus 2 equals 24x. And I'm going to distribute that x squared. So I've got x cubed minus 2x squared equals 24x. And I'm going to subtract 24x from both sides. And I can't combine it with anything. So we've got this. Now, I can't factor this right away because this is actually not a quadratic. Quadratic meaning highest exponent is a 2. This is a cubic, meaning the highest exponent is a 3. So the GCF between all three terms, I can take out an x. So you've now got this. And I care about factoring what's inside of the parentheses. So we've got negative 24 and negative 2. I can multiply 6 and 4 to get there, and I'm going to have a negative 6 because negative 6 plus 4 gets you negative 2. So you've got x minus 6, x plus 4 equals 0. So I'm going to take all of these factors and I'm going to set them equal to 0 to solve. So I've got x equals 0, x equals 6, and x equals negative 4. Our domain restriction here, looking at your two original denominators, I've got that x cannot be 0, and I've got x squared cannot be 0. This answer, x equals 0, is violating one of those domain restrictions. So that one cannot be one of my answers. So the only two answers you're going to get are the 6 and the negative 4. Okay. The last question, it's not going to be on your test. It's just kind of a bonus thing that we threw in there with graphing. Notice that you have a hole at 3, 2. You have a horizontal asymptote at y equals 1. You have a vertical asymptote at x equals 2. So we're going to use that information to help us solve. So remember that this is your general parent function. Since I have well, I'll add this in, that might help you. So your h here is equal to 2 because that's your vertical asymptote, and your k is equal to 1 because that's your horizontal asymptote. So when I put this information in, we get x minus 2 plus 1. But I have a hole at 3, 2. So that means that the x value of 3 is restricted for my domain. What would cause that to happen is if you had a factor of x minus 3 on the top and the bottom. So if I add 3 to both sides, that's where the x equals 3 is coming from. So I know I need to make a factor of x minus 3 on the top and the bottom. That's going to cancel out. That's going to generate the hole. Okay. So that means that when I evaluate this function at 3, the y value that I should get back is going to be 2. So wherever I see an x, I'm going to replace it with a 3. So I'm going to use the simplified function that's here because that's the one that would have the hole in it. So I've got 1 over 3 minus 2 plus 1. 3 minus 2 is 1. 1 over 1 is 1. 1 plus 1 gives you 2. So our function answer is this one right here. And when I evaluate the simplified version of that, the one that would have the hole in it, at 3, you get a y value of 2, which matches with the hole that you have on your graph. This concludes the review video. If you have any questions or anything that you need, you can either email me or you can ask me in class. Please look at this sooner rather than later because you are going to have to study for this test. It's not going to be something that you're going to be able to look at for 20 minutes before in the class prior to your test. So ask me if you have questions, and good luck studying.